Okay, so I don't think today people will join because last week I told that I'll be changing my time. So previously there were 3 days, now also there are 3 days. So previously the timings was Friday and 2 on Tuesday. So from this week onwards, it will be Friday, Sunday, and Tuesday. So one of the two Tuesday session has been shifted to the Sunday, which was conducted to me because I told in the last session that the rest of the 5 weeks I'll be conducting in Sunday. So there will be 3 more sessions this week, this month, and the rest of the 2 sessions will be in the next month, that is in the April. Okay. Sorry about that. There was a problem in the connections. So today I don't expect much people to join. Maybe there will be there might not be any attendance. I'm not sure. So I'll start the recording of my session. I'll record the entire session and then I will upload the recording and the presentation of the session for the sake of the people who will be watching it later. Okay. So let's start. Okay. So in the meantime, if the people join and if they have any doubt, I will be clearing their doubts. Okay. So let's start. So good evening. My name is Shutun Sadhukan. I am a teaching assistant at IIT Bombay and the facilitator of NPTEL course code C39 for the year of 2024. And I welcome the audiences to the session of the week 8. It is the 8th session of the NPTEL course named as Water and Wastewater Treatment, instructed by Dr. Bhanu Prakash Belanki, who is an environmental engineer at the Civil Engineering Department of IIT Roorkee. So today is March 17th. It is Sunday. And these are the rest of the sessions. So up to 30th of January to 12th of January, all the sessions are conducted in Tuesday, my sessions. And from this week up to the 16th April, the rest of the sessions will be conducted in the Sunday, 7 p.m. to 9 p.m. Okay. So today's session I will start with the description of different types of coagulation methodologies. So there are different types of coagulation methodologies depending on the process of coagulation that takes place. So coagulants, first those are added in the solution, and the larger particles gets attached with each other and forms lumps. In this way, they get separated from their suspended condition in the water. So what is solution, what is suspension, and what is precipitate of particles within water and their size ranges, we have discussed in earlier classes. So there are different types of coagulation methodologies are possible, namely charged neutralization, sweep coagulation, bridging, and patch flocculation. So in the case of charge neutralization, what happens? That positively charged particles are added inside the water, and if let's say the suspended particles are negatively charged in nature, that means their surface charge are negative, what will happen? That the coagulation's opposite charge will neutralize the negative charge of the particles. In this way, they get coagulated, or they get comes out once their charge gets neutralized. They comes out from the suspended condition and forms they attached gets attached together. And that means they coagulates and they forms larger particles and then precipitates. There is another type of coagulation that is called as the sweep coagulation. What happens in this case? Uh, if there is size difference between the charged particles, then we can see that surrounding one positively charged particles there may be negatively charged particle, or surrounding one negatively charged particle there may be multiple positively charged particles. So just like a sweep is used for cleaning the dust, what happens? There is only one sweep, and there are multiple dust particles are attached on the sweep, and in this way it is cleaned. If it is rubbed on the floor like that way, so it's worked on the principle of static electricity. Similarly, in case of coagulation, if this type of action takes place and the suspended particles coagulates and forms precipitate, this type of process is called as the sweep coagulation. Okay. Another two types of coagulations are bridging and patch flocculation. When you can see there are chains within the coagulant. So if the coagulants are basically polymer chains, this bridging type of coagulation and patch flocculation, this type of these two type of coagulation may takes place. So bridging means there will be uh, the polymers, the coagulant polymers will act as a bridge between the suspended particles. Uh, I hope it is anybody joined? No. So I think sharing got de-shared somehow. I'll again reshare it. Okay. Um, Nobody has joined. I'll continue. So, I'll continue for the recording 6, but I think today's session will be completed a bit earlier than the other sessions because there will be no interaction and no time will be given for solving the problems that will be coming at a later stage. Okay, so where are we? Yes. So if there are polymers which are used as coagulants, then there will be patches of flocculants formation that will take place inside the suspension or suspended solution. So in this type of coagulation is called as the patch flocculation. So these are the four major types of coagulation methodologies that you can see. So now our next question will be based on these different types of flocculation methodologies. So MCQ 1 is about the coagulation theory, which states that the net force on the colloids is repulsive at greater distances and becomes attractive only after passing through maximum net repulsive force, which is called as the energy barrier. Thank you, Harsha, for joining. We have just started. We have not discussed any question yet. So my session actually changed from Tuesday to. Okay, Akshara, welcome. So actually there is a change in the timing of the session. There was earlier one session, 3 TS are there, NPTEL-TS for this course. Because of the large number of audiences, though the people who are attending the sessions are less in number, but maybe later they will be, let's hope they are watching the recordings. And the session that was in Friday, that is still in Friday. The session which was in Tuesday, actually Tuesday there was two sessions. So one of the sessions was mine, which is shifted from Tuesday to Sunday. Okay, so the rest of the sessions will be on Sunday. That will be conducted by me, and one session will be in Tuesday, and one session will be in Friday. So Friday, Tuesday, and Sunday there will be three sessions. But in all of these sessions, the content that will be shared, those are almost similar. So you are always free to attend any or all of the sessions. That is up to you. Okay, you can attend any one according to your time. So let's resume our today's question. So I hope you have gone through Dr. Velanki's lectures. So if you have seen the idea about if you've seen the lectures and you are having idea about the coagulation theory, then you will be able to answer this MCQ. So this is the statement about the coagulation theory, and the MCQ is the above statement is relevant to which one of the following mechanisms. So option A is ionic layer compression, option B interparticle bridging, option C sweep coagulation, option D is none of the above. I hope you know different types of coagulation methodologies. So coagulation method, coagulant is added in a suspended solution, and the particles which are in suspended condition, they attached together and forms lumps. In this way, their particle size, if they're in a suspended conditions, their particle size is below 10 to the power -5 meter, that is in the micron level. If they coagulate together, their particles gets bigger and bigger in size, and they actually forms precipitate, right? So depending on the different types of methodologies, how the precipitates are formed, uh, the types of coagulations are decided. So there are many types as we discussed earlier. So it is ionic layer compression, interparticle bridging, sweep coagulation, and also patch formation may be there. Welcome Nandana, we have just started. Okay, so what type of what is the mechanism type that is related with the coagulation theory? The statement is as follows: the net force on the colloids is repulsive at greater distances and becomes attractive only after passing through maximum net repulsive force. The net repulsive force, maximum net repulsive force is called as the energy barrier. So please type your answer in the chat box. I'll wait for 1 minute, then I'll go to the answer. Okay, so I think if you have studied the if you have seen the lecture by Dr. Velanki, then you will be able to answer. Interparticle bridging, Nandana is saying. Harsha and Akshara, we also try. Okay, I'll move on to the answer. So it is basically ionic layer compression. Okay, so how the energy barrier concept is relevant for ionic layer compression, that I will show for you to clear your doubt. So the thing is that if you plot the distance between two colloidal particles along the x-axis and the attractive or repulsive energy in the y-axis, then for for the ionic layer compression, there will be an energy barrier. So if you cross the energy barrier and the distance between the colloids is below certain threshold level, then only you will fall into the energy trap. That means there will be attractive force acting between the two particles. Otherwise, the repulsive force will be more than the attractive force and it will not get coagulated. That means there must be high size difference between the uh, 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 differently charged particles. For example, in the picture as we see, the uh, the highly negative colloid is actually countered by the positive counter ion. So the positive counter ion are more in number and the negative ones are less in number. The negative though they are negative in nature, they are unable to repel the positive ions. They are actually compressed because of the highly negative colloid. And in this way, through the diffusive layer, they falls into the highly negative colloid and ionic compression occurs. Okay, so this is relevant for not interparticle bridging but the ionic layer compression, the energy barrier concept, because you can see there are, if the charged are similar ions, let's say this negative ion and this negative ion and the positive ions also, they are repelling each other, but after a certain distance, actually they falls into the energy trap, so they are getting attracted. Okay, so the energy barrier is overcome by the highly negatively colloid in this case. If let's say these particles are positive in negative in nature, the lightly colored particles, then this should be highly positive in nature to overcome the energy barrier. And once it crosses the energy barrier and falls in the energy trap, it becomes that means the precipitation becomes permanent. That means they don't disintegrate again and again goes to suspension. It doesn't occur. Okay. Okay, I hope it is clear. So let's move on to the next question. So basically, you have to match the typical water quality parameters with their respective categories. So in the right hand column, there are different types of water quality parameters like temperature, taste and odor, BOD and TOC. It is total organic carbon and biological oxygen demand. Pathogens, VSS and viral particles, salinity, hardness and heavy metals. And in the categories, there are chemical, physical, biochemical and microbiological. What types of parameters are they? That you have to say. Just keep the left hand order same. You can rearrange the right hand. So just tell me the rearranged right hand column number. You can type in the chat box, or you can unmute yourself and speak. So for those of you who joined late, so there are three TAs. There are three sessions. One was in Friday and two was in Tuesday. So among those two Tuesday session, one got shifted to the Sunday, that is today. So the rest of the five sessions, four or five sessions, those will be occurring in the Sundays only. One will be occurring in Tuesday and one will be occurring in Friday. You can attend any one of them. The content that is delivered in this session are more or less same. Okay, so now please type the rearranged order of parameters in the chat box. The ABCD one, you kindly rearrange it. It is not a very tough question, easy one. I'll wait for 1 more minute, then I will. Okay, Akshara is telling to physical means temperature, taste, and odor. Yes, I mean these are pretty common, so you can answer it like this way. 3 with B, biochemical, yes, that is also true. 4 with C, yes, microbiological pathogens, yes, and the rest one is your what is left? One is left. That means chemical. Chemical means salinity, hardness, and heavy metal. It is obvious. That is left. So whatever you have told, I hope you have told from your understanding only. I will not be explaining this. So whatever you have told, that is correct. The order is B, A, B, C. Okay. So let's move on to the next question. So it's a problem where a standard multiple fermentation test is run on a sample of water from a surface stream. The result of the analysis for the test are given below. So the sample size is in ml is given 1.1, 0.01 and zero point 0.001. Number of positives are 4, 1, 2 and 0. Number of negatives are 1, 4, 3 and 5. Okay. So you have to determine the MPN per 100 ml using the MPN formula as following. So MPN per 100 ml that we have to calculate, which is equals to number of positive tubes into 100 divided by root under ml of sample in negative tubes into ml of sample in all the positive tubes. I hope the formula is clear to you. I will wait for 4 minutes for you to calculate and give me the answer. can use your calculator, you can use your desktop calculator or mobile calculator or any other device as per your convenience. I hope the earlier questions, that is the different types of coagulations, is clear to you. If you are having any doubt regarding different types of coagulation, you can ask question. Otherwise, I'll assume those are clear to you. Which was required for answering the first coagulation question, because before anyone joined, I was discussing one slide regarding different coagulations. Okay. For this problem, Nandana is telling us 24.8. I'll wait for 2 more minutes for others to calculate. You can see one observation that in all the cases, the total number of tubes are 5, right? So this one is 4 and 1, 5. This one 1 plus 4, 5, 2 plus 3, 5, and 0 plus 5, 5. But in this way, they are not constant. This is 7, and in this way, these are 13. So from that table only, you will be able to get these data. Number of positive tubes, ml of sample in all the tubes, and ml of sample in negative tubes. You will be able to calculate the data from the table, put that data in the formula, and get the answer. I'll wait for 1 more minute for Akshara and Harsha. Okay, I'll give you the answer. So this is pretty simple. If you know the formula, the solution is as follows. So the samples are given, number of positives are given, number of negatives are given. Up to this table is given, and I am just taking the total of the number of positive tubes and number of negative tubes, as I told, 7 and 13. Now, how am I getting the positive samples and negative samples? It is nothing but you are multiplying the number of positives with the sample size. So 4 into 1, 4. For negatives, it is number of negatives into sample size. 1 into 1 equals to 1. Similarly, 0.1 into 1, 0.1, 0.1 into 4, 0.4. 0.01 into 2, 0.02. 3 into 0.01 equals to 0.03. In this way, this is 0 and 0.005. If you sum up them, then you will get the total amount of positive sample in ml, 4.12. If you sum up them together, that is the negative samples, you will get the uh, total amount of negative sample in ml. Okay. So this table is clear to you. So now let's put the data in the formula, which gives mpn per 100 ml equals to number of positive tubes you put from the table, 7 into 100, ml of sample in negative tubes, which is nothing but 1.435. You put that here. ml of sample in all the tubes, which is summation of the positive and negative tubes, that is put here. Now you can solve 700 divided by this root under 1.435 is nothing but 1.197915. This come out to be 584.35, and this terminology is 5.555, which after taking the square root comes out to be 2.357. By resolving, it should come 247.931. So I hope I am calculated it. I have calculated it correctly. So if Nandana, if you have any objection, you can tell. How did you get that? Maybe I think no. I don't know how you arrived it in this result, because maybe I think you have missed one point only. Yeah. You have missed one decimal place. That's how maybe you have got this. Right. Yeah, it is to 248. You have got 24.8. That's all. Maybe you have somewhere you have missed one decimal place. Or if I am wrong, you can. If I am wrong in my calculation, you can tell me. Okay. I hope it is correct. We will move on to the next problem. Next MCQ. So the main concern of water planners in allocation of water among competing uses is option A, maximizing profits through financial returns, option B, obtaining optimal value in terms of market and welfare measures, option C, providing more water supply for economically higher class as they can pay more, and option D is providing free water services to the poor class consumers. Which one among these is the main concern of water planners when they are allocating water among the users? You can type your answer in the chat box. Earlier problem, I hope all of you understood. I'll wait for okay. This I think, should I wait or I'll wait for a minute, 1 minute. Just type your answer in the chat box. Okay. So I think nobody is coming forward. I'll tell you the answer. So the correct answer is uh, obtaining optimum value in terms of market and welfare measures. Okay. Okay. Akshara is telling us C. That means providing more water supply for economically higher class. No, actually, because whoever plans the water allocation, those are mainly government agencies. They don't seek for profit. They just allocate the water based on the tariffs set up for the running of the plant. So for the sustenance of the plant and for the paying of the maintenance costs only. Okay. So the explanation is as follows: making maximum profits through water service may not contribute to welfare of all sections of the society. So the main concern of water planners is to allocate water to obtain optimum value in terms of market and or welfare measures. So both market and welfare measures comes into the picture. Not only the, if you are considering only the economically higher class, then uh, I mean the lower class people will not get water supply. So water planners should not plan water accordingly. And if you provide free water service to poor class consumer, what will happen? They may exploit the resource. Right. Just in some cases, in some places, you will see in some cities, older cities, you will see there is water from time taps. That means from this time to this time, 7 a.m. to 10 a.m. Let's say, the municipality will supply water free for free. And what happens? People will actually keep the taps open, and the entire, I mean, the water that will be supplied will be entirely lost, even if there is no need. So that's why providing free water services is also, it is an exploitation of the resource. And maximizing the profits, because water is a service thing. Maximizing profit should not be the target. So there must be a balance between the market and welfare measures, which is the correct option. Okay, I hope it is clear. So now we'll okay. I hope my internet connection is lost. Sorry, actually my connection got lost. So yeah, let's resume. What is happening? Okay, okay. Sorry about that. Actually, my connection got lost. So I already shared the screen. Yeah. Hope it is visible. Uh, I am also loud and clear, right? Okay. Okay. Thank you. So let's continue. Mm. So next MCQ is the core objective of Namami Gange project is pollution abatement and rejuvenation of the river Ganga. Option B, developing major irrigation based project beside river Ganga. Option C, establishing major hydroelectric projects on river Ganga. And option D is all of the above. Which one among the following is the core objective of Namami Gange project? Uh, or all of them? So maybe you can think it in terms of the course. Yeah, it is an water and wastewater treatment course. So why the other options will be there? But let's say what happens. What is the right answer? Let's see. So Namami Gange project is an integrated conservation mission approved as flagship program by the Union government in June 2014 to accomplish the twin objectives of effective abatement of pollution, conservation and rejuvenation of River Ganga, which all of you have correctly said. Option A is the correct answer. We will move on to our next MCQ. The water utility of a town increased the water tariff by 6%, which saw a reduction in the demand from 16 mld to 14 mld. The price elasticity of the demand is. So there is a decrease in demand of 2 million liters per day, and there is an increase in water tariffs uh, of 6%. So calculate the price elasticity of the demand. Do you know what price elasticity is? If you don't know, then I will I will solve this problem. Otherwise, I'll wait. So option A is 1.28, option B is 0.48, option C is 0.125, and option D is 1.75. You have to mark the correct option. It is basically a ratio. The price elasticity of demand is okay. So I'll proceed with the solution. I'll not wait. The other two, I mean, Akshara no, Nandana and Harsha also don't know, right? Okay. I'll, if you know, tell me to wait, otherwise I'll, okay. So it's basically a ratio, no major big deal. So explanation is the data given is the demand reduction is given as 2 mld, tariff increase is given as 6%, and as I told, the price elasticity is nothing but the ratio between two things. So ratio between the two percentage. So as it is price elasticity, so the price term will be in the numerator and the percentage decrease of the demand will be in the denominator. So how do you calculate the percentage decrease in demand? It is 16 minus 14 by 16, which gives you the fraction. That means 1 minus 14 by 16. That means 1 minus 7 by 8. That means what? 8 minus 7 by 8. That means 1 by 8. 1 by 8 gives you the fraction of fractional decrease of demand into 100 equals to 12.5% is the percentage decrease in the demand, and 6 is the increase in tariff. So if there is a reduction in demand, what may be the reason? Because of the increase in the price. So people actually reduce their water usage because of the increase in the water tariff. In last class, actually, we discussed on forecasting the population, because the water demand is proportional to the increase in population, right? So in this class, we are comparing the price with respect to the population in this problem. So ratio between these two, 6% and 12.5% is nothing but 0.48. So option 2 is correct. No major big deal. So price elasticity is just the ratio of the percentage change in demand, percentage change in price with respect to the percentage change per percentage in demand. Okay. So if you see there is a decrease in the price, naturally there will be an increase in the demand. So if one is negative, another one is positive. So in both of the cases, whether the price increases or decreases, the unit of the price elastic demand will be the same. So that's why you have to take the mod value. All right. If you see there is sign given in the question, then only you take the sign. Otherwise, generally mod values are given and mod values are taken. So it's basically a sensitivity thing. So you can see there is a change in the demand, and you can see there is a change in the price. So what is the change in the price with respect to change in demand? So it is basically it is denoting a sensibility. It's a sensibility factor, right? Okay. So now we'll so how sensible is change in price with respect to change in demand? It is basically the price elasticity of demand. Okay. So now we'll move on to our next problem, the next MCQ. So major issues in water sector in India includes option A, deteriorating quality of water resources due to anthropogenic activities. Option B, reduction in per person freshwater availability due to increase in population. Option C is lack of effective infrastructures for ensuring efficient water services. And option D is all of the above. So all of the above are basically issues related to water sector, but which issue is specific to India? That you have to tell. All of you have watched recordings of the earlier classes, right? Or you have watched any one of the sessions you have attended, right? Because sometimes what happens while taking current session, TAs actually refer to their earlier sessions. So that's why it is important. But any one you can watch, not necessarily all three, or you have to attend. It is not mandatory. Okay. I hope this problem, this question, are you able to answer? Please type your answer in the chat box. So whether for due to anthropogenic activity, that means the man-made thing. So the human activities. So whether for that reason the quality of the water resources is deteriorating, or for the increase in population, the per person freshwater availability is getting reduced, or lack of effective infrastructure is uh, leading to the lack of efficient water services. Which one among them is true? Nandana is telling A, Akshara is telling B, and Harsha. What do you think? If you think all of them, then also it's okay. So all of these problems are basically problems in water sector, but in case of India, also all of the listed issues are prominent. So option D is the correct answer. Both of you are correct. Option B and A are also true. And option C, that is the lack of effective infrastructure for ensuring efficient water services, is also true in a country like India, which is not highly scarce in water, and also water. It is not a water surplus. It is in between. That is, I mean, there is a terminology called water deficit, right? So water scarce, water deficit. These are all terminologies in terms of water availability. So if you will see there is a source of water, and you see there are consumers, but because of lack of effective infrastructure from the source to the consumer, the water is not getting delivered. This type of for this type of lack of delivery, whichever water scarcity is generated, it is called as the economic water scarcity. So this economic water scarcity, that is the option C, is also relevant in case of India. So all of the above the correct answer. Okay. Now you have to rearrange the following in the correct order. The correct order of economic analysis procedure of a water supply project. So the pointers are survey of existing facilities, uses and constraints, if any, least cost analysis with economic price and choice of alternative, demand analysis and forecasting, and identifying gaps between future demand and existing facilities after optimum use. So if you are doing an economic analysis of a water supply project, then which one you should do first and which one you should do the last. We have to rearrange the order. Today, actually, I started late. You also joined late. So I want to be your and be giving any breaks. So if you want a short break, you can tell. Otherwise, I will not give any break. So we'll continue. Okay. 1432. All of you are telling us 1432. Okay. Let's see. So the explanation is first, the survey of existing facilities, uses and constraints will give an overview of water utilization. So option 1 will remain in its place. Further, doing demand analysis and forecasting can help to compare it with previous utilization data, and that can help in identifying the gaps if required. So demand forecasting and gap identification. Then choosing alternatives and performing economics prices is important. That means number 2 will come in the last. So the first and last, all of you have stated it correctly. But the in between, you have all of you have said 1432, which will be basically your 1342. That means the demand analysis and forecasting will be first. Yes, and then you have to identifying the gap between future demand and existing facilities for optimum use. Because if there is no demand, there is no use of the gap identification. So it will be 1 3 instead of 4. If you have any objection, you can say. Why is it so? So if you do any kind of analysis, you first see whether it is a greenfield project or a brownfield project, right? If greenfield project means there is no existing facilities. Brownfield project is there are these existing facilities. So then you analysis what is the market demand. You forecast the market demand basically based on past data. If the demand, the forecasted demand is such that the existing facilities will not be able to meet that demand, then there is a need for the capacity enhancement. If it's so that the existing facilities are enough to sufficient for the meeting the future forecasted demand, then there is no need for enhancement of the capacity. So you do the analysis of the existing facilities, you do the demand analysis, then you identify the gap, that whether capacity enhancement is needed or not, based on the existing facilities and the demand data, right? Which is the option, which is the number four. So after three, four will come, and then two you have studied correctly. So cost analysis and choice of order, it should come at the last. So I hope three and four, these two are clear to you, right? Okay. So now we'll move on to our next MCQ. The conventional sources for water supply include option A, only rivers and lakes, option B, rivers, lakes and groundwater, option C is groundwater and rainwater, and option D is rivers, lakes, groundwater and recycled sewage. Which is the conventional, all of them actually can be your sources for water supply. Which are the conventional sources? That is the question. Option D. All of them are sources for water. Are the recycled sewage conventional sources? It is not, I think, because previously whatever sewage was there, that was directly thrown to the environment. But it is currently, nowadays, it is not permissible. So that's why recycled sewage is also used for the as a source of water supply. In Singapore, they call it as the new water. There's a term called new water in Singapore, which is nothing but the recycled sewage. But this is not a conventional source of water. Akshara is telling us B, rivers, lakes, and groundwater. I also think it's so. Let's see what is the correct answer. So the explanation is groundwater and surface water, that is rivers and lakes, are conventional sources for water supply. Whereas rainwater is also, rainwater harvesting is a new concept, right? It was not there in before 2000. So whereas rainwater and recycled sewage are considered the alternative sources. Okay, so these are not conventional sources. So Akshara has told it correctly. Option B is the correct answer. Okay. So now we'll move on to our next MCQ. What are the traditional three R's of sustainable development? Option A, reduce, reuse and reserve. Option B, reduce, reuse and recycle. Option C, recycle, repeat and reuse. And option D is reserve, recycle and reuse. Huh. You please type your answer. Harsha is not answering. This is very common in industry. And even not in industry. I mean, if you have studied in school level the environmental science, if you have studied, if you are, or in your college level, if environmental studies was in your syllabus, then you might have come across the concept of 3R. Okay, so all of you are saying as reduce, reuse, and recycle. So the 3R stands for that only. Option B is the correct answer. This rule is part of the waste hierarchy, which is a process used to protect the environment and conserve resources through a priority approach. Now, next MCQ. In developing countries like India, the sector that consume the highest amount of fresh water is option A, domestic, option B, industry, option C, power, and option D is agriculture. All of these sources consume water. So in India, which sector consumes the highest amount of fresh water? That you have to say. Which sector water use requires treatment, or which sector water use don't require treatment? You can see domestic water, there is treatment needed. So that's why sewage treatment comes into the picture. In industry, uh, treatment is again needed. But in power sector, is water needed, treatment needed? I don't think so, because there will be steam that will be generated from the power sector. High pressure steam and low pressure steam. Steam means distilled water. So I don't think it requires further treatment. Maybe some unit operations may require treatment in power sector, and agriculture sector may or may not require treatment. Depend on your what is the if high amount of uh, let's say chemical fertilizers are used for agriculture, then it may lead to eutrophication of the water bodies. So that's why agriculture. But if it is not used, then agriculture sector does not need the treatment of water. But the highest amount of water that is used is as follows. So agriculture is the highest water consuming sector in developing countries, and so is the case in India. So all of you have said it correctly. Option D is the correct answer. That is agriculture. Okay. Now we'll move on to our next MCQ. The typical range of water in liters consumed by a person in a day to fulfill the domestic needs is option A 250 to 350, option B 100 to 200, option C 700 to 900, and option D is 400 to 600. Per capita demand of water typically in a day in liters to fulfill in order to fulfill the domestic needs only. Okay. No, no, you have not said. Okay. Please type your answer in the chat box. Option B. Akshara is saying as option B. Option B, no, no, no. Harsha. It's a memory question, memory based question, no concept. But you, yes, you, you may relate with whatever amount of water you are typically using in your home. Let's say people at max generally drinks 6 liters of water, right? 5 to 7, it varies. Maybe more or less than that also. But it will not cross 10 liters per day. So it will be remain in one digit only. But the other uses you just imagine. So how what might be the possible answer? Harsha. Others okay. I'll tell it anyways. I'll wait for 1 minute for you to guess. Okay, so I'm also saying B. So the typical per head water demand ranges between 100 to 200 liters per day. All of you have guessed it correctly. Next, the process by means which water continually changes its forms and circulates between lands, oceans, and atmosphere is called as option A hydrological cycle, option B tides, option C ocean currents, and option D is moisture recycling. You can type your answer in the chat box. Yeah. Yes, this is very easy question. What cycle it is? In layman's terms, it's called as the water cycle. So you have studied in your school level. From the ocean, the water gets evaporated by sunlight, taking the sun's energy. It remains in the cloud. It goes over the glaciers. It actually rains in the terms of snow there. Gets deposited, and from there the water through the rivers again comes into the ocean. In this way, it is called as the water cycle. So, what is the technical term? That's what they are asking. Nothing else. Okay. So, I think both of you are correct. Hmm. So it is nothing but the hydrological cycle only. The hydrological cycle of the earth is the sum total of all processes in which water moves from the land and ocean surface to the atmosphere and back in the form of precipitation. So option A is the correct answer. Okay. So now we'll solve a problem together. A project worth of rupees uh, 1.5 crores of a mineral water bottling plant is to be established. If the value of the project is likely to be depreciated using straight line method for over 5 years with 35% salvage value, calculate the annual average depreciation of the project in lakhs of rupees. So this straight line method, you don't get confused by the term. It is we can modify it. It gets decreases linearly. That's all. So it's likely to be depreciated linearly. Okay, okay. It is. It has gone. Yeah. So I'll tell you how to calculate the pricing. Very simple. So this is the total worth of the project, right? And it has to be depreciated linearly. That means the straight line method for over 5 years with 35% salvage value. Salvage value means after 5 years, it will be the cost of the project. So you take 35% of this 1.5 crore. That will be the salvage value. Now you just take the uh, you subtract the salvage value from the worth of the project. So 1.5 crore minus 35% of the total project cost. That means what? 65% is the amount of depreciation for over 5 years. Now they are asking what is the depreciation per year, annual average depreciation of the project. It is the per year. So you have to calculate it in terms of lakhs of rupees. That's all. Okay, so it is the 13%. So you can see 65% is the depreciation, right? This is 100%, it is 35% salvage value. So how much got decreased? 65%. Over the 5 years. Linearly it got decreased. So per year depreciation will be 65 by 5 equals to 13%. 13% of what? Unit is in lakhs of rupees. So 13% of the project worth. So total value is given as 1.5 crores. Salvage value after 5 years is 35%, that is 52 lakhs and 50,000, and annual average depreciation is 100 minus 35% by 5 equals to 65% by 5 equals to 13%, as I told, which is nothing but the entire difference by 5 or 13% of 1.5 crore. In any way you can calculate, it is rupees 19.5 lakhs only. This is the answer. Okay. So in lakhs of rupees, it will be 19.5. 19.5 LPA, lakhs per annum. This is the correct answer. Okay, now next, in my first class, I discussed about molality, and normality. I hope you remember that from your earlier school, from your school days, or if you had science in your +2 level, then you will be able to remember them, or I'll repeat them. So concentrations of solutions are expressed in terms of this M or N. So what is molarity? It is expressed as moles of solute per liters of solution. Symbol is capital M. Units are moles per liter. Molality is expressed as the moles of solute per kg of solvent. Symbol is M, small m. And units are moles per kg. So you can see it is liters of solution and it is kg of solvent. If the solvent is water, then the density of the water, that is 1000 kg per meter cube or 1 gram per cc, that you have to consider while calculating molality or molarity as per the question. But the denominator remains the same, moles of the solute. Okay. So it is expressed capital M, it is expressed as small m. And what is normality? Normality is gram gram equivalents of solute per volume of solution in liter. So volume of solute in liter means 1000 divided by volume of solute in ml. Right? Or have I said something wrong? Yes, because you can 1 liter means 1000 ml, right? Okay, let's say, so mass of solute, if it is given in grams, then you have to know the equivalent mass to calculate the gram equivalence. So to calculate the equivalent mass, you have to know the concept of valency. Let's say you are given a compound as calcium carbonate, then its weight would be, weight means it is the molecular weight or molecular mass, which will be calcium is 40, carbon is 12. I hope you know these things, the atomic mass. This concept is known to you, I think. And if it is not known, please tell. I'll explain. Otherwise, I'll proceed. And oxygen's atomic mass is 16. So 16 into 3, it will be 48 plus 40 plus 12, 52. So 52 plus 48, it will be 100 for calcium carbonate. It is its molecular mass. Okay. So now calcium carbonate can be dissociated into water in calcium 2 plus and carbonate 2 minus ion. Its valency in this way. So you can see there is a 2 charge. So that's why its valency is 2. So equivalent weight of calcium carbonate becomes weight of calcium carbonate, which is 100 divided by the valency 2. All right. So the equivalent weight of calcium carbonate is 50. Now, if let's say you are given 200 grams of calcium carbonate, so what will be the gram equivalence of solute? It will be 200 by 50. That means mass of solute in gram divided by equivalent mass. That means 4 will be your gram equivalent. If let's say it is given as 500, then it will be 10 gram equivalents and so on. Right. So if you are getting the data in terms of ml, then to convert it into liter, you have to multiply it with 1000, right? Because within 1 ml, if this is the gram equivalence, then in 1000 ml, that is liters, it will be into 1000. This is the concept of normality. I hope this is clear. So now we will solve certain MCQs and problems based on these concepts. In the first class, we also solved. This class we will also solve. I hope this is clear. Any doubt? Please tell. I'm currently in Jalpaiguri. I have got certain cold. Okay. So I'll start the questions based on the concept. So there is a problem at first where a chemical supplier is reporting the concentration of stock alum chemical as 9.58% as alumina. Alumina is Al2O3 with a specific gravity of 1.32. You have to calculate the molarity of alumina, Al3 plus ion. Molarity, I hope it is clear to you. The difference between molarity, molality, and normality. You have to calculate the molarity. This is the first thing. And the second thing is alum may be in any form. They are reporting the concentration of alum in the form of Al2O3. That is aluminum oxide or alumina. So the concentration of alumina is 9.58%. And the specific gravity means if you compare the stock alum chemistry, stock means stock solution. If you compare the solution mass with the mass of water of same volume, that will come out to be 1.32. It is 1.32 times heavier than normal water. Then you have to calculate the molarity not in terms of alumina but in terms of Al3 plus ion. So can you calculate? I'll wait for 4 minutes for you to calculate. The problem that was solved in the earlier in the day one's class based on the M and N concepts, molarity and normality concepts, those are very easy. But now it's a bit tough because you can see the density is in some other form. Not density, the concentration is in some other form, and you have to calculate the molarity in some other form. So the concept of the weight and all, so number of moles, how to calculate the number of moles. This is important. You know, right? How to calculate the number of moles. Otherwise, I'll explain. Number of moles means the weight of a particular species divided by the the molecular weight of that particular species. That means the number of moles. Okay, okay. So I have to explain. Uh, Nandana and Harsha for you too also. Okay, I'll learn it. So you can see the data given. It is the stock solution of the alum. You can see the stock solution of the alum chemical is given as 9.58% as Al2O3. 9.582% of Al2O3 means what? Rest is water, water or whatever else. So alumina Al2O3 will be 9.58 weight% plus 100 minus 9.58. That means 90.42 weight% will be the rest of the things. The Al2O3 will be 9.58% and the rest of the things will be 90.42%. These are all weight percentage. Now, the density of the stock solution will be 1.32 times than that of water. So water's density is 1 gram per cc or 1000 kg per meter cube. You multiply it with the specific gravity of the stock solution of alum, which is 1.32. After multiplication, it becomes 1320 kg per meter cube. It is the density of the stock solution. We calculated the density of the stock solution based on its specific gravity. Okay. Specific gravity is nothing but the ratio between two densities, where the denominator means the water. Okay. Now, hence, 1 meter cube of stock solution contains uh, you see 1 meter cube of stock solution. You weigh it, it will be 1320 kg, right? And within that 1320 kg, that means 1 meter cube of stock solution, the alum is present as 9.58 into 1320 by 100. So 9.58% of this will be the weight of the alumina in 1 meter of stock, 1 meter cube of stock solution. Okay, so 126.456, and if you subtract this from 1320, the rest the things 1193.544 will be the other things which is not alumina. Okay, so hope it is clear up to this point. Any doubt, you please tell me to repeat. Okay, so these are all the data given, or we have calculated based on whatever data is given. Now the solution goes like this: Al2O3 alumina equals to 27 into 2 plus 16 into 3. 27 is the molecular weight of or molecular mass of alumina, this many grams per mole, into alumina. 2 plus 16 is the for oxygen into 3. So this is 54, this is 48, equals to 102 gram per mole or kg per kilomole. This K cancels out, it becomes gram per mole, simple same unit. So this is the molecular weight of the alumina, Al2O3. Is it clear? Hopefully clear. Any doubt? You ask. Now 1 meter of stock solution contains how many kg of aluminium? That you have to calculate first. So you see, 1 meter cube of stock solution contains Al2O3 weight of 126.456. Among these 126.456, how many is the aluminium? Okay, so Al2O3, right? Its molecular weight is 102, and there are two aluminum atoms. So it is 2 into 27 equals to 54. So if you multiply this weight with this factor 54 by 102, you will get the kg of aluminium present in 1 meter cube of stock solution. Hope this is clear up to this point, right? Any doubt? Please tell me to repeat. So now, what is the expression of molarity in terms of alumina? Not alumina, aluminium 3 plus ion. So if you express the molarity in terms of Al3 plus ion. It is moles of solute, that is aluminium, per liters of stock solution of alum. So अगर क्वेश्चन में ऐसा बोलता कि calculate the molarity in terms of Al2O3, then you have तुमको इधर Al2O3 पुट करना पड़ता. Okay, so moles of aluminium parts liter of stock solution of alum is the expression of molarity in terms of Al3 plus only, because if this is 3 plus and everything, the ionification doesn't affect the mass much, right? So now this term can be written as kilomoles of aluminium per meter cube of solution of alum. How? So you convert these liters into meter cube. That means you have to multiply 1000 in the denominator. So 1000 liters becomes 1 meter cube, and you have to multiply 1000 in the numerator also. Then moles becomes kilomoles. 1000 moles means kilomoles. Hope this is clear up to this point, right? Now, meter cube of stock solution of alum remains the same. Kilomoles of aluminium you calculate like this way. So if you solve this, this is the kg of aluminium, 67 kg of aluminium, divided by, you are dividing it with 27, which is the atomic weight of aluminum, atomic weight of aluminium. That gives you kilomoles of aluminium present in the meter cube of stock solution of alum, which is nothing but your molarity in terms of Al3 plus, not in terms of Al2O3. If it was told you have you calculate this in terms of Al2O3, then this would be your answer, 126.456 divided by 102. So maybe 1.24 would be the answer. But here they are asking it in terms of Al. You can see there are two Al, so Al2O3. So that's why 1 mole of Al2O3 gives 2 moles of Al. So that means it is multiplied by 2. So whatever molarity in terms of alumina, that is the half of the molarity in terms of aluminium, because there are two aluminium atoms present inside one molecule of alumina. No, sir. Which one is no, sir? Which one is not clear to you? Have I calculated anything wrong? Let's say let's recalculate it. So this goes like this way: 126.456 into 54 divided by 102. No, it is correct. 67 only. Oh, no doubt. Okay, okay. Okay, okay. So I hope then for the rest for the rest of you two are also good. Okay, Nandana has left. Okay, Harsha, I hope you are able to understand. Maybe Nandana was bored. It is pretty obvious for her, I think. So that's why. But in Jobio, this session is for general understanding only, because many people are coming from very basic background. They may not understand, so that's why we discuss this session from very basic. And you have always option to watch the recording. If you feel that your time is wasted by watching this, you can go through the slides also that will be shared in later stage. Okay. So now we'll proceed to our next problem. Here you have to calculate the concentration of again alum using the data that was given in the last question, and you have to express the concentration of alum in terms of gram per liter. This thing. This is the proper expression of alum, which is called Fort-Curie in local language. So Al2SO4 whole 3 dot 10H2. Within one molecule of alum, there will be 14 molecules of hydrogen bounded in one alum crystal. Basically, this is in a crystal form. So now you have to express the concentration of alum in grams per liter using the data given in the last question. So last question data was what? The density was given, right? 9.28%, and the density was given in terms of Al2O3 only, and you have to calculate the concentration in terms of this thing, that also in grams per liter. So in last problem it was 9.58 weight percentage. Can you calculate, or should I? Oh, Nandana rejoined. Hope last problem you understood well. So now using the data we will be solving this problem. So I'll tell you the solution. So the data given is again in the from the past question is 9.58 weight percent of alumina. Rest is the other things. The density of this stock solution is 1.32 into 1000 kg per meter cube. That means 1320 kg per meter cube. That means 1320 grams per liter. So this kg per meter cube and this gram per liter, these two are same units. I hope you know that. So you divide this numerator with 1000, it becomes gram, and you divide the denominator meter cube by 1000, it becomes liter. Kilo hecto deca liter, kilo hecto decameter, decicenti millimeter. That means one cubic decimeter means 1 liter. 1 meter cube means 1000 liter or 1000 cubic decimeter. That means 10 to the power 6 cc or 1 mega cc. 1 mega cc or 1 million cc, that means cubic centimeter, means 1 meter cube or 1000 liters or 1000 cubic decimeter. Okay. Now we will so hence previously we told 1 meter cube of stock solution. Now we are telling us 1 liter of stock solution. Instead of kg we have put gram here, right? So 9.58 divided by 100 whole into 1320 becomes 126.456 grams of alumina, and the rest is the other things again. So this concentration you have to express in terms of this. So to express it, again we calculate the molecular weight of alumina, Al2O3 plus O3, Al2 aluminum oxide, I'll say it. So it becomes 2 into 27 plus 6 into 3, 54 plus 48 equals to 102 gram per mole or kg per kilomole. And this alum, you are calculating it. Again, you are calculating its molecular weight. So it is Al2SO4 whole 3. Al2 means 27 into 2, 54 plus 3 into sulfur is 32. Oxygen is 16 into 4 equals to 64. Okay. So this one is for this one. And hydrogen is 2 plus oxygen 16 equals to 18. There are 14 hydrogen molecules, so 14 into 18 equals to, this term becomes 342 and 14H2O becomes 252. Okay, summing up, it becomes 594 gram per mole. Now, 1 liter of stock solution contains this many aluminum oxide. This many aluminum oxide means, so here we are comparing it in terms of mole. So you can see in 1 molecule of alum, there is 2 aluminum atoms. And within 1 uh, molecule of aluminum oxide, there is 2 aluminum atoms again. So 1 mole, if you consider aluminum as the basis, then 1 mole of aluminium, sorry, 1 mole of alum is equivalent to 1 mole of aluminum oxide. So that's why we are considering 1 mole here and 1 mole here. That means 102 gram, 594 gram. To calculate these factor, 594 by 102 into these grams of alum that is present within 1 liter of stock solution. Okay. So now you simplify this one. This factor 594 by 102 became 5.824, and you multiply it with this 126.456 grams of alum per liter of stock solution of alum. That became 736.42 grams per liter. So you have converted this 9.58 weight% of aluminum oxide to 126.456 grams of aluminum oxide per liter to 736.42 gram of alum per liter. So from this to this to this, you have converted. I hope it is clear. Okay. So you can anything if it is given to you, you should be able to convert. If let's say calcium hydroxide is given to you and calcium carbonate is given to you, CaOH2 and CaCO3, you should convert it in terms of, because calcium is the key element here. So 1 mole of calcium carbonate is equivalent to 1 mole of calcium hydroxide, and you should be able to interconvert their concentrations. Let's say you are given as Na2SO4, sodium sulfate and sodium chloride, NaCl, or maybe NaOH, sodium hydroxide. Then that will be different, because 1 mole of sodium sulfate, Na2SO4, is equivalent to 2 moles of sodium hydroxide or sodium chloride. So there, this factor, as it is in this question, you can see this, there is 594. We have considered 1 mole of this and 102, 1 mole of this. So if it is not, it is not equivalent. Just like I gave the example to you just now, sodium chloride and sodium sulfate and or sodium hydroxide. So in that case, you have to multiply it in one either in denominator or in numerator, depending on what is given in the question. You have to multiply it with 2. Did you understand that? So it is based on the mole equivalence. Okay, so I hope the concept is clear to you. If you have doubt, please stop me and again ask. So now we will move to our next MCQ. What happens when alum is mixed in water as a coagulant? Option A, pH will be decreased. Option B, pH will be increased. Option C, both can be possible. Option D, no change in pH will be there. If you are mixing alum in water as a coagulant, you have seen the expression of alum in earlier, right? Al2 Al2SO4 whole 3 dot 14H2. You leave the 14H2. Now you see the Al2 and the what Al2 and SO4. SO4 3 is SO4 2 minus. With if the alum is dissociated in ionic form within water, it will be Al3 plus 2Al3 plus and 3SO4 2 minus, right? If you know how to uh, get the expression of ionically dissociated components of a molecule, then yes. All right. So it's works. The alum works just like H2SO4, right? In the case of H2, there is just Al2. Okay. So yes, so pH will be decreased. All of you are correct. So now we will solve a problem. If a 12 parts per million of alum dosage is required for the treatment of water, then the quantity of alum in kgs for the treatment of 10 million liter water will be how much? That we have to calculate. I'll wait for 2 minutes. ppm means what? Parts per million. Parts means what? Parts per million means what? Kg per million kg. That's all. Million means what? Nijut. So একক দশক শতক হাজার অযুত লক্ষ নিযুত কোটি. 0.1 crore is 1 nijut. The translation of nijut is in English it is called as million. That means 10 lakhs. 100 crores means 1 billion. Million, billion, trillion. Trillions means what? Trillions means 1000. 1 billion means 1000 million. 1 trillion means 1000 billion. And 1 quadrillion means 1000 trillion. Yes. So quadrillion, then billion, then million. Sorry. Yes. Quadrillion, trillion, then billion, then million. Here their coordinates as million. So parts per million means kg per 10 lakh kg. Yes. This is basically parts per million. So 12 kg per 10 lakh kg of water. It is given, right? Or 0.1 crore kg of water is given. Then you have to convert it in terms of kg per 1 crore liter of water. Simple, very simple. You calculate it. Tell me the answer. Yes. So 10 million liter means 1 crore liter means 10 to the power 7 liter. Density of water is 1000 kg per meter cube. That means 1 kg per 10 to the power minus 3 meter cube. 12 ppm of alum means 12 kg of alum per million kg of water equals to 12 into 10 to the power minus 6 kg of alum by 10 to the power minus 3 meter cube of water. Okay. Which is equals to 12 into 10 to the power minus 6 kg alum per liter of water. Hence, the alum quantity in kg for the treatment of 10 million liter of water will be, so this 10 million liter means what? 10 to the power 7 as I have calculated earlier. Okay. and the alarm required for 1 liter is what? 12 into 10 to the minus 6 as we have calculated. So we put these two things. And 10 to the minus 6 into the 7 becomes 10. 12 into 10 kg means 120 kg is the answer. Hope it is clear for, oh, Nandana has calculated 115. So do you have any objection in the way we calculated, or you understood your mistake? Nandana, please speak. And Harsha, have you understood? Okay, okay, okay. So Harsha, have you understood also? It's clear. It's very easy. Okay. So now we will move. How many minutes time left? 5 minutes is left. Okay. So now we will move to our next MCQ. Sorry, it is an MSQ. MSQ means multiple select questions. That means one or more answer may be correct. So in water treatment, a jar test is performed to find the chlorine of chlorine content of water, to obtain the optimal dose of coagulant, to find out the optimal time required for flocculation, to find optimum pH at which coagulation needs to be done. So jar test is performed for what reason? So there may be more than one answer may be correct, or one answer also may be correct. Chlorine content, coagulant dosage, uh, flocculation time, and coagulation pH, optimum pH for coagulation. Which one is determined using the jar test? Chlorine content, coagulant dose, flocculation time, coagulation pH. I will wait for 2 minutes for you to think. Jar test is a memory based question again. There is no concept. Problems, numericals, or conceptuals, these are memory based questions. Simple. Harsha is telling us B. Akshara is telling us B. Optimal coagulant dose. And Nandana, do you agree with that? Or you want to add something more? Or are you satisfied with B only? All of you are from which backgrounds? I hope maybe you are doing or have done your bachelor's, right? Or you are in school level attending NPTEL. I don't think so. I think all of you have done your BSc or BTech or whatever, right? Okay, MSc. Currently pursuing MSc. Okay. No, no, no. What are you doing? MSc in what subjects? Harsha and Akshara? In chemistry based subjects, right? Chemistry or environmental. Maybe that's why you are attending. One was saying as option B and C. Okay, so time required also you're telling. See, a jar test is essentially a chemical based test. Option C. Let's see. So that's why option C is not, so the time required is not uh, found out. So it's a chemical based test. So that's why you might have said chlorine content of water. That would be perfectly fine, because uh, in jar test chlorine content is chlorine content is a chemical based test. But though in jar test it is not found out. But time required is will never will be able to find, because it is not a chemical based thing. That's why option B and D are the correct answer. It's just a memory based question. No uh, concept is involved in it. So we'll move on to our next MCQ. You have to find the respective concentrations, molar of iron. Respective molar concentrations, right, of iron and chloride. Iron is Fe3 plus, chloride is Cl minus in a 3 molar FeCl3 solution. Option A is 2.2 and 6.6. Option B is 3 and 9. Option C is 1 and 3. Option D is 1 and 1 respectively. So a FeCl3 solution is given to you, and you are told that the concentration of the solution is 3 molar. If it was small m, then it would be molal, but it is not small m, it is capital M, so this is molar. So 3m it is given to you. You have to calculate the same molar concentration in terms of Fe3 plus and Cl minus. So you will see you will understand the difference, and you will also understand why it was so in case of the alarm problem, if you are able to understand calculate it correctly. All are saying as option B, I think. Both of you are correct only. So option B is the correct answer. Yes. So you can see 1 mole of FeCl3 is 1 mole of Fe3 plus. That means 3 mole of FeCl3 is equivalent to 3 mole of Fe3 plus. So molar equivalence is same. So that's why FeCl3 is 3 mole, Fe3 plus is also 3 mole. But you can see 1 mole of FeCl3 implies 3 moles of Cl minus. That means 3 moles of FeCl3 implies 3 into 3, 9 moles of Cl minus. So this is the correct answer. Hope Nandana is also able. So now we end our session here. It is time's up. So if you have any doubt regarding your previous sessions that has been conducted, or in today's session also, if you are still having any doubt, you can ask. Otherwise, we'll close the session. No doubt. Okay, so let's conclude it. Goodbye. See you in next Sunday, 7 p.m. Okay. Bye. Good night. I'll stop the recording.